Hello and welcome back to another mid-year exam question. This is the 2020 mid-year exam, criterion 6 and question 3. So we have in this question, we have two resistors are wired up as shown in the diagram below. We have a 6-volt battery or power cell, a 3 ohm resistor and a 7 ohm resistor here connected in parallel. Calculate the total resistance of the circuit. Because they're in parallel, it is this formula here, R1 times R2 over R1 plus R2. And just a friendly reminder that they are on the formula sheet here, R1, R2 over R1 plus R2 there. Okay, that's in parallel. So it does tell you. And we have R1 times R2 is 3 times 7 over 3 plus 7, which is equal to 21 over 10, which is equal to 2.1 amps. Okay, pretty straightforward there. Good. Calculate the total current in the circuit. V equals IR, so that means that we have I is equal to V over R, which is equal to 6 over 2.1, and if we put that into our calculator, we should get 6 divided by 2.1, and that is equal to 2.86 amps. Oh, what did I do before? I said amps up here. That's not amps, is it? It's actually ohms. Ohms. Okay, and we have 2.86 amps there. Calculate the power output of the 7 ohm resistor. So if we go down here, power is equal to V squared over R. We've got them all the different types here, VI, I squared R, or V squared over R. So P equals V squared over R, which is equal to 6.00 squared over 7.00. So 36 divided by 7, or 6 squared divided by 7, is equal to 5.14. Is that right? 5.14? Yep. 5.14, and that's watts. Alright, question 3. In a different circuit, a 3 ohm resistor and a 7 ohm resistor are connected in series to a power supply with an unknown voltage. Draw a diagram of the arrangement, including a voltmeter to show the voltage across the 7 ohm resistor and an ammeter measuring the total current. Alright, so we're going to go with our power supply there. I'm going to put an ammeter at the start. Then I'm going to use these symbols for resistors. You could use the squiggly ones. That's our 3 ohm. That's our 7 ohm. And our voltmeter goes in parallel, although we want to, actually draw the V in first. Sometimes it's easier to draw that in first, and then like this, like that. Okay, that's our diagram. If the voltmeter is showing a potential drop of 8.4 across the 7 ohm resistor, show that the power supply is providing 12 volt to the circuit. So the key to this one is remembering that I is the same here, I is the same here, I is the same here, I is the same all around the circuit. Okay, so that means that the current going through the 7 ohm resistor is the same as the current going through the entire circuit. So this is our V total being supplied to the circuit. So our current I is equal to, in the 7 ohm, 8.4 divided by the resistance. So remember, V equals IR, so I equals V over R. And you can always draw your little V IR triangle there, like that, if that helps you remember. V equals IR, so 7, and this is equal to, going to our calculator, 8.4 divided by 7 is equal to 1.2. So the current is equal to 1.2 amps. So if we want to look for our V total, it's equal to the total resistance of the circuit, it's equal to I times R total. And remember that R total, if we look at our thing here, you just add the resistors together. Resistance series, you just add them all together. So V total I is the same everywhere. 1.2 times by 3.0 plus 7.0. So it's equal to 1.2 times 10, which is equal to 12 volts. Okay, so that's pretty good. Just going to make that look, oops. Let me make that look a bit nicer. V total. Okay, 12 volts. Explain why parallel circuits are usually used for wiring lights within the home instead of a series circuit. Okay, so in a parallel, if we look at a parallel, we could take out one of these. So let's say we took that one out, then current would still flow through the 7 ohm. So let's say, imagine there were two light globes. If one of them blows, then current will still flow in the other. Whereas if this was the circuit and we blew one of these globes, then it would not, the circuit would be disconnected and we wouldn't, no more current would flow. So in parallel, a light bulb could blow, but the other globes in parallel would continue to allow current to flow. In series, oops, it's not spelled series. Writing a little bit quickly, aren't I? Can't write properly. In series, if one globe blows, one globe blows, not bowls, the circuit is disconnected and no current would flow. And that is it. Okay, that's the whole point. Right, so question 4 will be in the next video.